So it's possible to actually model, using physics, the motion of pretty much any object. And the way we do that, it's called 1D kinematics, the study of motion in one dimension. This means we're only going to be dealing with forward, back, left, right, one dimension of motion. So we're not going to have a ball thrown at an angle, because that would be both up and down and forward and backwards. So only one axis at a time. But given that, it's still relatively powerful. So the variables that we're interested in relating are the ones that we've heard about when we've talked about motion. So we're interested in position, which is represented by x. Initial velocity, which is represented by v naught. V naught this is how it's read, it's v sub 0. And the 0 is still a velocity, it just means the 0 says this is what the velocity is when it starts. Final velocity is represented by v sub f. Acceleration is represented by a, time is represented by t. We're going to get to this stuff down here in a little bit. So the four equations we have relate four different combinations of four variables from the left panel. So our first equation gives position, or change in position. So this is x, which is our position, and it's equal to velocity times time, initial velocity times time. This is something most of us are familiar with, have seen before. Even intuitively, it makes sense. If you travel for a certain velocity for a certain amount of time, you're going to travel this amount of distance. But we also have to account for acceleration, and that's why we add in this term of 1/2 at squared. We have another equation for position, which does position in terms of initial and final velocity. So basically, if you know the initial velocity, you know the final velocity, you can just average the two and multiply by time, and that's going to give you how far you've traveled. Our third equation says your final velocity is however fast you were traveling at the beginning, plus whatever acceleration you had for some amount of time. And then our last one relates, again, final velocity, but this time in terms of position. So if you have a final velocity, initial velocity, acceleration, and position, then this relation holds true. And you can see over here, I listed what four variables each of these equations are relating. And this can be useful when we're trying to solve a problem. So when you're trying to solve a problem with kinematics, there are four steps that you need to do. The first step is list what you know and what you want. And we can do that right here. We can say what we know, what we want, and we can make a little table. So let's do a sample problem. Let's say I drop a ball, or let's say a ball is dropped from a height of 3 meters. What is its final velocity? So, anytime we're doing a problem like this, we need 3 things in the no category and 1 thing in the want category. And you might have to sometimes parse what this question is asking in order to get these lists. So, if a ball is dropped, an alarm should go off in your head. Anytime you see the word dropped, it means that initial velocity is 0, because if I drop something, it's not moving before I drop it. And also that it's going to accelerate with the acceleration due to gravity, which all objects feel when they, or any runner. And that is 9.8 meters per second squared. So, immediately we can write down into our list, we can list that we know that the initial velocity, v naught, is equal to 0, acceleration is equal to 9.8 meters per second squared, and we want, well, let's see, we're dropping it from a height of 3 meters. So height is a distance, so that gives us our position, x, which is equal to 3 meters. And it asks what is its final velocity. So we're looking for v sub f. So we're going to relate x, a, v naught, and vf. So basically, those are the 4 you have. Go through here and see which equation matches your needs. So that's step 2. Step 2 is choose your equation. And in this case, it matches this one. So we're going to choose vf squared is equal to v naught squared plus 2 times a times x. And then our final step, 3, is plug in and solve. So, if we're going to plug in and solve into here, we're looking for final velocity. So final velocity will stay as its symbol. And if we wanted to solve for x or something, you can just rearrange this equation to solve for x. So just because something is here doesn't mean you can't use it to solve for anything else. You can use it to solve for any of the four. So vf squared is equal to v naught squared, which is 0. So this is 0 squared plus 2 times 9.8 meters per second squared times 3 meters. So you have that vf squared is equal to 0, 2 times 9.8 times 3. Well, 2 times 3 is 6. 6 times 9.8 is a little bit less than 60, so I'll say it's about 60 meters per second squared, and this is meters squared because the units multiply. So then your final velocity is equal to the square root of 60, and this will be in meters per second. So that is basically how you're going to approach every single kinematics problem. First, list what you know, what the problem gives you, and what you want to find. 2, just figure out which equation you want to use, and you can do that using which 4 variables does each equation here relate to each other. Make sure you also you're picking up on any keywords. If you ever see at rest, it means that a velocity is 0. If an object starts at rest, initial velocity is 0, ends at rest, final velocity is 0. And your last step is to just basically take the equation you chose, plug in what you know, and find what you don't know. And that is going to be how you approach every one-dimensional kinematics problem of this style.